everyone. Welcome to another bonus episode of Molecast, where we're celebrating the researchers and the research that has been awarded Nobel Prizes this week. Today's prize was the Nobel Prize in Physics, and the winners of this prize were Dr. Roger Penrose, Dr. Reinhard Genzel, and Dr. Andrea Ghez. And they were awarded the Nobel Prize in Physics for their research regarding black holes and black hole formation. So the prediction was that black holes were possible from some work from Einstein's general theory of relativity. But the big question that remained in the field was, did they actually happen? And I don't know about you. I am not a physicist. I am a molecular biologist. I only remember physics from high school and college physics. So I really had to go into the literature to understand what black holes were and why this research was so exciting. And even though I still read, the articles that came out, and I was like, okay, that sounds really great. And when I talked to fellow mad scientist and friend Justyna, she was incredibly excited that the Nobel Prize was awarded to these three researchers. So I invited her today as a guest commentator, just so we can understand why this is such a big deal for physics and for society in general. So before I introduce Justyna and have her give her thoughts, I was going to just give some background information for the general audience on black holes, the general theory of relativity, and why this research in the scientific community is important. So just so we're all on the same page, what is a black hole? And no, a black hole is not what my mother describes my room being when I was growing up, which is basically just a mass chaos space. But actually, a black hole is a place in space where gravity pulls so much that not even light can get out. And the gravity is so small because matter has been squeezed into a tiny space. So imagine taking something the size of Earth and squeezing it down to the size of a pea. And black holes can be really any size. They can be big or they can be small. An atom that's about the size of an atom actually has the mass of a large mountain. And there are different sizes of black holes that are classified as either stellar or supermassive black holes. A stellar black hole is when the center of a very big star, bigger than the sun, collapses. And this causes a supernova. And a supernova is essentially just an exploding star that's able to launch part of itself into space. However, a supermassive black hole is so large that it's the center of the galaxy. And keep that tidbit in your hat, because we'll get back to it later. So let's go back in time, get into our imaginary spaceships, time machines in our head. And we travel back to the time of Einstein. And Einstein created a general theory of relativity. And when I read this, I'm not going to kid you guys. I was like, what is the general theory of relativity? Like, I recognize it, but it's not clicking. I know Einstein very well as being an amateur violinist and an amazing physicist, and someone that I look up to and admire as being able to balance both their love of science and their love of classical music. But if we dig deep into Einstein's general theory of relativity, at the time, the classical account of gravitation was from Newton. And what Newton said was that Earth wants to move in a straight line. However, a gravitational force from the sun deflects it and causes it to move in an elliptical orbit around the sun. However, Einstein's theory was the very presence of the sun disturbs or curves the very fabric of space and time, so that the Earth moves inertially in this new disturbed space-time. And I read that and I was like, okay, that's a lot of words. But if we think about it in terms that make sense to us, it's a little easier to understand. So most of us here are classical musicians. So let's put these two terms in the sense of an orchestra. And we're not talking a professional orchestra. Let's talk about a nice youth orchestra or an amateur orchestra. And in an amateur orchestra, we see the conductor. And the orchestra tends to want to rush. There's that one part where no matter how hard we try, and we see the conductor's baton give us a clear 4/4 beat, the orchestra is always rushing. But the force of the conductor is causing us to want to stay in time. So even though we're rushing, we still look up at the conductor as he bangs on his baton, follow this beat, and we steadily go back into the 4/4 rhythm. However, take that same amateur orchestra and introduce an amazing soloist. Doesn't have to be a world-class soloist. Can be someone who's, getting their PhD in violin performance. And just the mere presence of that soloist, the orchestra will automatically follow that soloist through heck or high water. If the soloist rushes, we will be there. We will rush with that soloist. If the soloist wants to drag out the phrase, no problem. We will follow the soloist till kingdom come. So that's how I understood in my framework Newton's classical account of gravitation with Einstein's general theory of relativity. The very presence of the sun is causing the Earth to move inertially in this new disturbed time space. But Einstein did not believe that black holes really existed. When Einstein died, 10 years later, Roger Penrose studied the formation and stability of black holes. And I was checking out the server earlier today, and one of our members, Maria, was commenting, oh, wow, Roger Penrose, why was he awarded a Nobel Prize in physics? He's a theoretical mathematician. Well, here's the thing. Penrose used his expertise in mathematics to create these ingenious mathematical proofs that proved that black holes are a direct consequence of Einstein's general theory of relativity, and that the formation of a black hole was essentially inevitable and would be indestructible because it would grow as it ate more mass. So this proof was the birth of the idea of black holes. But the question remained, do these actually occur in space? Well, let's introduce two new researchers, Reinhard Genzel and Andrea Ghez. And what they did was they focused on a region in the center of our galaxy, the Milky Way, a region known as Sagittarius A. I think it's Sagittarius A star. I'm going to refer to it as Sagittarius A. Apologies in advance if that is incorrect. And just so you guys understand how large this region is, Sagittarius A is 4 million times the mass of our sun. Like, our sun is big, but this is much bigger. It's huge. And both groups agree that an extremely heavy invisible object is pulling on the stars around Sagittarius A, causing them to rush around. And when I talk about rush around, the stars that are rushing around this area are taking years to go around the galaxy. Earth is actually taking 230 million years to do the same thing. So it really shocked these scientists, like, wow, why are these stars going around this area so fast? So what did they do? They built unique instruments and they refined their techniques to compensate for distortions caused by the Earth's atmosphere. And what they were able to do was give us convincing evidence of a supermassive black hole at the center of the Milky Way. This is the best evidence that we have thus far. And if you're still not convinced, they also use these techniques to identify another supermassive black hole at a neighboring galaxy, M87. So this was huge. Not only was were black holes postulated by Roger Penrose, but they were proven by 2 additional researchers to possibly be true. So where does the field go from now? Genz explains that the modern theories of physics still can't really explain when something falls beyond the point of no return. And they're currently trying to image Sagittarius A, but so far they've been unable to produce conclusive results. I also found this as another fun fact, that this is Andrea Ghez is actually the 4th woman ever to win a Nobel Prize. And this prize is $1.12 million. Half of it will go to Penrose, and the other half will go to Genz and Genzel. So 4th Genz and another 4th Genzel. And I, again, like last episode, I want to put in this quote that was from Genz during her interview with the Nobel Committee. I hope that I can inspire other young women into the field. It's a field that has so many pleasures. And if you're passionate about the science, there's so much that can be done. And I found that to be really, again, confirming the research and the scientists and the passion that we heard about yesterday, that passion and perseverance is incredibly important for pursuing anything that you're interested in. And with that, I'm going to go ahead and introduce Justyna. Justyna, as you guys know, is our server owner here at the Science Server. And she also, her research focus is also in physics. And I'm sure she has a lot of amazing impressions to give us on today's awardees. So without further ado, welcoming Justyna.
Hello.
Hey, Justyna, how are you?
I'm good. So yeah, I was today going through some papers and some other publications regarding black holes, and I was just hyped today by those announcements, and why it was so exciting for me. By the way, I'm not astronomer. To be clear, I'm not astronomer. My research is more focused on particle physics, not astronomy. But anyway, it's not so far one from another. Astronomy is very hot topic. I looked at the previous Nobel Prizes from last year's, and I wrote down the four Nobel Prizes during the last 10 years were connected to astronomy. For example, in 2019, it was the Nobel Prize from last year. It was for contributions to understanding of the evolution of the universe and Earth's place in cosmos. So it was also connected to astronomy. In 2017, it was also connected to astronomy. It was for gravitational waves and LIGO detector. And in 2015, it was for neutrino oscillations and neutrino mass. It is maybe not directly astronomy Nobel Prize, but somehow connected, I would say. And in 2011, it is for accelerating discovery of accelerating expansion of universe through observation of distant supernova. So, as you see, astronomy is super hot topic now, and actually a lot is going on here. So, if you are planning to go in physics in the future, if you are planning career in physics, astronomy is a good choice, definitely. a lot is going on, and and this year is Nobel Prize is for black holes. And the second reason why I'm so excited is, of course, Moa already said it before, is that a woman was awarded. It is fourth woman awarded from I think over 200 people awarded with the Nobel Prize in Physics. So it is really something, and I think it is very inspiring for girls to go into science, and I hope that it is.
Yeah, no, I definitely agree. I definitely agree. I know we have this echo thing going on, so I'm trying to keep my mic muted, so you don't have the interference on your end. But no, I definitely agree. I think this is a really exciting occasion for women and girls that are interested in going into STEM, for women in STEM fields. Since this is the fourth time ever that a woman has been awarded the Nobel Prize. I also found it really ironic because 2020 has just been this chaotic, like, growing year of just what is going on, that the Nobel Committee was like, we should really award black holes this year. I just found it, I was like, I see what you did there. Even though the research itself is super fascinating. And just like I said yesterday, it's not only these three researchers that contributed to the study of black holes. There are hundreds of other researchers that also contributed. Dr. Oppenheimer, you guys may recognize Stephen Hawking, also contributed to the study of black holes. But these three, one, because they're alive, and two, because they've greatly advanced their field with all the research that they've done, definitely deserved recognition for all of their efforts. But we also should applaud those that also help contribute to advancing the field and advancing our understanding of the galaxy. But I did want to ask you, Justyna, when you said that a lot of Nobel Prizes in physics have been recently awarded to studies in astronomy, why do you think that is? And do you think it's just because other aspects of physics haven't advanced as quickly as astronomy, or it's that we're waiting to confirm the studies that we've had that are currently ongoing in other aspects of physics to make sure that they're sound?
Well, I think that the reason is that so there is so very good that you asked this question, because there is also one thing that I wanted to point out, and it actually matched this question. So the Robert Penrose theory actually came up in 1965. Well, it was almost over 50 years ago. So it is long time. And so why was he? Yeah. So why is he awarded now? Why not 50 years ago? So same thing happened with in 2013, I guess, when the Nobel Prize for Higgs boson was given. Also, the creator of the theory of Higgs boson was awarded, and the theory was known also for a few decades, I would say, and why the theorists wait so long for the prizes? Well, because the answer is simple, because the theory have to be proven by experiment. So why the astronomy is hot now, I think it's because we have technology now good enough to actually prove some theories which have been developed during decades till now, and now we can take them and prove them. And that's why now we can speed up the research, because now that the technology is incredibly speeding up the research.
Oh, cool, great. Yeah, I was just wondering, because as soon as you said that astronomy has been kind of dominating the awards in the Nobel Prize for Physics, I was like, but that does make sense.
Yeah,
and we did mention that yesterday too.
But also not only astronomy, because there is also a lot of optical fields. Like there is also laser research in Nobel Prizes, in also some semiconductor research and so on. So these fields influence each other, like, you know.
Yeah. Oh wow. Yeah, I didn't even realize. I totally forgot about optics and the semiconductors as well. Optics totally blew my mind. But yeah, that's amazing. And what do you see? I know you introduced yourself at the beginning that you're not an astronomer, but are there any additional points or questions that you have as the field moves into the next decade, ignoring the chaos of 2020? We'll imagine a brighter future. Do you what questions does the field face, and where do you see the field heading in the future?
Well,
and I say physics as a whole, not just astronomy.
Yeah, well, definitely I see physics going into exploring the standard model and what is beyond the standard model. I mean, dark matter and dark energy, whatever it is and wherever it is, because we still don't know. And yeah, that is actually what is close to my field. And for sure, in semiconductors, there is also a lot of going on there. And optics. There is also semiconductors and optics. There is a lot of going on in these fields, also because those fields are strongly connected with new technologies, with also with building quantum computers and so on and so on. So
cool.
We'll see where this will carry us.
Oh, cool. Awesome. Yeah. Thank you so much just for giving us some further insight. When I saw the awardees this morning, I was like, oh man, I've got my work cut out for me. But then just having just your excitement and enthusiasm and just having just someone who understood more about the field gave me reassurance and okay, I can understand this too. This isn't that bad. But just having someone who can really explain it in terms that we can all understand is greatly appreciated. And if you guys enjoyed our discussion of the Nobel Prize in Physics, don't forget to tune in this Sunday, 10 a.m. Eastern Standard Time, where we're going to discuss the physics of music. The announcement is both here on the science server and in the main server, Ray Chen Violin. And that podcast will be conducted in one of the practice rooms on the main server, Ray Chen Violin. So hopefully we'll see you there if you guys want to hear some more about physics and how it relates to classical music, and listen to some of the experiments that are being done by scientists here in our server. And also, thank you guys so much for tuning in to another bonus episode of Molecast, and thank you so much to Justyna for her contributions and insights into the awardees today. Tomorrow is the Nobel Prize in Chemistry, so we'll be back here 7 p.m. Eastern Standard Time discussing the research and the researchers that are awarded the Nobel Prize in Chemistry. With that, I hope you guys have a good day, good evening, and have fun exploring the world around you. See you guys soon. Bye.